Hello, this is the second video of chapter 2. So in the previous video we learned how to calculate the conditional probability. We learned its definition, and now in this video we are going to consider real data. So we will think about this research question. Does smoking increase the risk of high cholesterol or not? So the basically question is pretty similar, but we are going to use the real data from National Health Interview Survey from 2018. We have more than 7,800 observations, and we have two survey questions. I take only two variables from the website, and the two variables are about smoking and whether a person is prescribed for medicine to lower cholesterol. So basically, diagnosis for high cholesterol. So I will show you the data. So I'm going to upload this data with the slides. So these are the two variables we have, and let me show you the sample space. For the first variable, possible answers are yes or no. If yes, that means the person has high cholesterol. The person needs medication to treat high cholesterol. And to the smoking, also, the answer is yes or no. So yes means the person has smoked, and no, never smoked. What we are going to do is we are going to use these two variables and study the effect of smoking on high cholesterol. So we are going to define notation this way. S stands for smoking and H stands for high cholesterol. So now, then, what are the conditional probabilities that we need to compare? Remember, we would like to estimate the risk of high cholesterol for those who smoke compared with those who never smoked, right? So think about this question. This is the most important question because if you cannot answer this question, it doesn't matter if you know how to calculate the conditional probabilities. You have to understand what you need in the first step. Okay, if you need more time to think about it, pause the video. Otherwise, let me explain. So, like in our previous example, we compared the probability of promotion between men and women. In here, what we are going to do is, the framework is the same, we are going to compare the probability of high cholesterol between those who smoke and those who never smoked, right? So then the main event that we are interested in is the probability of high cholesterol. So the first event should be H. We are looking for conditional probability of H conditional on smoking, right? Conditional on smoking or non-smoking. So the answer is C. So the first conditional probability is the probability of high cholesterol given that the person smokes. We compare this with the conditional probability of high cholesterol for those who never smoked. So the answer is C. Okay. And then let me calculate the probability from the data. So we learned how to calculate the 2x2 probability distribution table. The idea is choose Insert tab here and click Pivot Table. Pivot Table. And then if you click OK, then you are going to have some panels. Here I'm going to just bring one down here. So columns, ever smoked, rows, high cholesterol. And drag another variable to here. Then it gives us the frequency distribution table. There is no blank, so I'm going to just turn this off just for better look. And this is count, frequency, the number of observations for each type, for each outcome. And we change the count to percentage. Then we obtain the probability distribution table. This is what we get from the pivot table. So same thing here, right? As you see, the only difference is yes and no. The order has been changed. If you wanna flip this, maybe you can sort from Z to A. So yes first and no. And then this is the 2x2 table, 2x2 probability distribution table. Now, how can we get a conditional probability, not just the 2x2 joint probability? The answer is we go here again, value field settings, and then click this tab. And what we are going to do is we are going to choose percentage of column total or row total. So now we are going to choose column total. So then if you choose this, we calculate probability for each column. This is exactly the conditional probability. So for example, some of these two probabilities become 100%. That means, so we calculate probability of yes among these two types. Similarly, among these two types, only among these two types, we calculate probability of high cholesterol or not. So that is the conditional probability. Okay. So the first column shows us the conditional probability conditional on smoking, conditional on those who ever smoked. And the second column, second probabilities are the conditional probabilities given that a person has never smoked. That's what we get here, how we calculate conditional probabilities on Excel from real data. Okay, by the way, so that's just Excel function, but let's see how we can calculate if you don't have Excel, you just have these joint probability distribution. How can you calculate the conditional probability? So we would like to calculate conditional probability of high cholesterol among those who ever smoked, right? Among smokers. And then the idea is the same, but the difference from the first video is that in the first video we had frequency table, but now we have joint probability table. So, but idea is the same. We are going to delete the observations, the probabilities that that do not satisfy the condition. We are not interested in these types, and then calculate the probability of the event we are interested in among the types that we are interested in, the smokers, right? So there are this many smokers represented by the probability. So this percentage of people are smokers, and out of them, only this much have high cholesterol. So if you calculate these numbers, you get 80.11%, which is exactly this number. That's how we calculate conditional probability from joint probability. Okay, so then we can formulate that idea like this. Conditional probability of A given B equals denominator being the probability of the condition, right? The pool size is in the denominator, and the numerator being the probability that the condition is satisfied at the same time the main event occurs, right? So two conditions. Condition should be satisfied, B is the condition, and then the event A should occur. So high cholesterol, smoker. This is actually equivalent to frequency. So it doesn't matter whether you have frequency or probability. The main idea is we are going to adjust the pool size, the denominator, right? Denominator. So in the previous example, we considered conditional probability to adjust the pool size between men and women. Similar, in here, we have to adjust the pool size, the size of the number of people who have the smokers versus non-smokers. So the denominator includes condition and numerator as joint probability. Now it's your turn. So now calculate the probability of high cholesterol given among non-smokers, okay, from the joint probability table. So try this. Okay. So now, idea is simple. Again, we are going to delete the first column. Non-smokers are only here, so delete this side, and then calculate probability out of this much. Out of non-smokers, only 37.49% have high cholesterol. Then you get 71.30%. Okay? So this is the probability of high cholesterol among non-smokers. And we calculated the probability of high cholesterol among smokers. So smokers have higher probability of high cholesterol than non-smokers. So it's a comparison we can make. Okay. So then what we can learn is, so here in this example we learned the relationship between joint distribution to conditional joint probability and conditional probability. So this is the formula we defined how we define the conditional probability. Simply, if you move this term denominator to the other side by multiplying the same denominator on both sides, then you are going to get this. This is called general multiplication rule. Remember, in the previous chapter, we learned the addition rule. The addition rule is to express the probability of union using simpler probabilities, especially when two events are mutually exclusive. The probability of the union can be expressed as the addition of simple probabilities. Now, we call this multiplication rule because the intersection can be expressed as a multiplication. The probability of the intersection between A and B is multiplication of two probabilities. So it's called general multiplication rule. Later, I'm going to introduce you a special multiplication rule. So it's kind of, the structure is parallel. In chapter 1, we learned general addition rule and special addition rule under special condition. And now we learn the general multiplication rule, and later we are going to learn special multiplication rule under another assumption. And the previous chapter, the addition rule was for the union, and multiplication rule is for the intersection. So you can compare how they look. They are different, but have similar structure. Also, we may interpret it more intuitively. The left-hand side, the probability of intersection between A and B, can be interpreted as the probability that the event A and the event B occurs at the same time. And on the right-hand side, I would interpret it this way. First, I check if the event B happens or not. So this is unconditional probability for B. And then check the probability, like check whether B happened or not. And then if B happens among the observations that B already happened, then check whether A happened or not. That is the conditional probability. So left-hand side checks whether A and B happens together or not, but on the right-hand side it's sequential. Check B first, and then if B happened, then check A, right? It's that's another way to understand the multiplication rule. Okay? So, and just one more exercise. What is the probability of not having high cholesterol problem, not having high cholesterol among smokers? Okay, so it is also very straightforward to calculate that. We are going to keep these observations, and delete this column, and among these two types, we are interested in H complement, 9.43%. So out of this many probability, what is the ratio of 9.43? You calculate this way. You may use the formula. Anyhow, you are going to get these numbers. Then your answer will be about 19 point something percent. What I want to say here is, it must be clear to you now. Once you delete this column, second column, then there are only two possible outcomes, whether you have high cholesterol or not. Anyhow, there are only smokers now. After deleting non-smokers, you have only smokers. Then there are only two types. That means among smokers, certain probability of people have high cholesterol. And then exactly the remainder does not have high cholesterol. That is this probability. So what I'm saying here is the probability of high cholesterol among smokers plus probability of not high cholesterol among smokers must be 100%. Anyhow, they are from the same pool, so their denominators are the same. So their sum should be always 100%. This is just the complement rule for conditional probabilities. So it is obvious because it's a matter of the denominator, how much pool you have in mind when you calculate the probability. And then once you set the pool, define the pool denominator, then it's whether it happened or not. So the sum should be always 100%. Okay, so what I'm saying here is, like what's confusing here is, complement is placed here in the main event, not on the conditioning event, right? So, and not both. So it's, you have to fix the condition equal, and then the whether it happens or not is attached to the main event. Then you can apply the complement rule. Okay, this is it for the second video. There will be more videos to come, so see you there.